Hello guys, in this video I would like to explain about heat map and its application in various areas. You can see that the map on the slides, and that's the temperature for the days of the month. Days are given on the right on the y-axis and months are mentioned on the x-axis, and you can see there is a bar which can show about the temperature. So this is a very nice map, heat map, and which you can use in various areas, and this is one of the important part of the data science process. You can use this in the data science and machine learning and statistical analysis and various areas. This video is limited to the theory of heat map. That what is heat map, what are the types of heat maps, and what are the applications of heat maps. So we will talk about these three things, and in the next slides I will explain that how you can create heat maps in Python and R. So let's start that this video. That what is heat map, what are types of heat maps, and what are the applications of heat maps. So now you can see what is a heat map. A heat map is a data visualization technique that represents values using a color gradient, making it easy to identify pattern, trends, and anomalies. It is commonly used in statistical analysis, geospatial data, and machine learning to explore complex data sets. So just go back to the figure, and yeah, like this, the first slide, you can see that what you listen in the definition, you can see all the things. So suppose that we are looking for a pattern, and you can see this is map is for daily maximum temperature using data from the NASA power. These are the days of the month 1, 2, 3 up to 31st days, and these are the months on the y in the x-axis. On the y-axis days, and the x-axis months. 1 mean January, 2 mean February, 3 mean March, and 12 mean December. So you can see there is cold in this region, and in January it's very cold. I mean, look at this, you can see temperature below than 15 degrees centigrade, and still in February also you can see low, and then it's becoming warming, and in the May there is warm, and in the June the warmest is June, and that is from 22 to 22 and 23 are the warmest days in this year, because these are the days and these are the months. So you can see this year, and this bar on the right side show about the temperature. You can see that I start from below than 15 and reach to 40 plus, and you can see there's can be 42 or something like this temperature on June 22 and 23 and a particular year. So you can see the pattern, you can see the things, so very obviously. If you 0 times use data, maybe you will unable to explore, but if you use heat maps, you can see a lot of information, pattern, structure in the data set, which is what we are using normally in the data science. So that's about heat map. And now types of heat maps. Matrix based heat map used to visualize correlation matrix, contribution matrix, and etc., which we use normally in the data science process and machine learning. So matrix based can be used for these purposes. A special heat map used to represent special data over geographic areas. For example, temperature distribution. So yeah, you can use this as well. If you have the temperature data and you know about the area, so you can plot this, and you can see, so you can get some nice information about the distribution of temperature. Time series heat maps display data variation over time, often used in climatology and finance. So you saw the maps in the beginning of this video. So that was about daily maximum temperature over time. Clustered maps use hierarchical clustering to group similar rows, columns for pattern detection. So you can use for this purpose as well. If you have data on two variables, rows and columns heating, you can do this type of to to detect some pattern group similar, station or whatever. Now, let's come to the applications of heat maps: climate and environmental science, temperature and precipitation analysis, visualization of seasonal and annual climate variations. So we have done, in the beginning of this video for maximum temperature, but you can do this for seasonal and annual climate variation. Just, you have data and you can plot. You should have two variables, like one is on the y-axis and one is on the x-axis. You can plot and you will see some nice information about temperature and precipitation analysis, maybe superiority power temperature and superiority power precipitation. Just two draw parallel plots and you see what is happening, or what has happened. Drought monitoring using satellite-based indices, for example, SPI and SPEI for post-temporal drought assessment. You can do drought assessment as well. You have data on the droughts, and you have special, information, special map. You can plot and you can see CO2 emissions analysis, mapping special pattern of global carbon emissions. So you can do this as well. We have done this in one paper. So you can do this as well, and you can see some nice information. Therefore, is more emission and where is less emission. Hydrology and meteorology. The second one is hydrology and meteorology, flood risk mapping, identifying flood prone areas using precipitation and elevation data. So you can do this. You can use this when you have precipitation data. You can see where as the highest amount of precipitation, and you can see the potential areas and threats of of flooding in different areas. Extreme weather events, detecting hotspots for cyclone, wildfires, and heat waves. Yep, yes. If you have data on these variables, you can detect hotspots for cyclone, wildfires, and heat waves. River flow and water quality monitoring, analyzing special temporal variation in river discharge and pollutant levels. So if you have data on river discharge and pollutant levels, you can do river flow and water quality monitoring. You can do this as well. This will give you some information about this pollutant. Now see, machine learning and data science, future correlation analysis, understanding the relationship between input variable and machine ML models. So you can do this as well, and you have the information about input variables, and on ML models, or you can say dependent variable. You can draw a heat map and you can see you can feature correlation, and you can have some important information about the relationship. And there is one map, there is one graph you can develop shape, which SHAP, that is abbreviation for I don't know, remember now, but you can use that as well to see the relationship between dependent variable and the contribution of independent variable factors, you can say. Model performance evaluation, visualizing confusion matrix for model for classification model. In the classification case, you can visualize confusion matrix, and that is, of course, you can do that like in the heat map, and that can give you make it easy to conclude about the performance of the model. Hyperparameter optimization, tuning ML model using height maps for parameter selection. So if you have enough information, you can do this for optimizing the hyperparameter of machine learning model. The health and epidemiology, disease spread mapping, visualizing epidemic outbreaks, e.g. COVID-19 cases. So if you have data on COVID-19 and you know about you have geographic information, like globally or maybe regionally, you can visualize and you can see whereas the highest threat about the spread of some particular disease like COVID-19 and maybe other diseases as well. Air pollution impact, assessing pollution related repository disease using spatial heat maps. So if you have the related information, which data is required for this air pollution impact, you can develop heat map, geographical heat maps, geospatial, and then you can see where as the highest pollutant, where is the highest impact of the air pollution. And finance and economics, stock market analysis representing price volatility and trend over time. So if you have the information about price volatility and trend, you can develop a heat map these variable with time, and you can see what is happening in the stock prices. And if you are using historical data, you can see what happened in the previous time to the price volatility and trend. Economic indicator mapping, visualizing GDP, inflation, and unemployment data across regions. Again, this is geographical maps, so you need information about GDP, inflation, and unemployment, and you can draw this over different geographic region, and you can see what happened to the GDP in the previous times, what was the inflation, and what was the unemployment situation in different regions. You can compare it very easily. And I mean different regions. Urban planning and transportation, traffic density visualization, identifying congestions, hotspots in the cities. If you have data on traffic intensity and for different times, I mean for different hours of the day or for different days of the week, particularly or different hours of the day, you can draw. I mean, on you have data. You should have a variable like. Let's go back to the first this one. You will have number of hours here and number of week here. So you will have this plot for hours, traffic intensity per each day of the week. That will be here. 7 days of the week will be on the x-axis and 24 hours on the y-axis. And you will see where is the highest traffic intensity on which day at which time, and when is the lowest traffic intensity on which time at which time and on which days. So you can do like that. It's very nice application as well. Crime mapping, highlighting high crime areas for low enforcement strategies. So you can do like this as well. You have geographic information, you have data on the crime, just map it over that geographic location, and you can see where we need more enforcement strategies and where we need less enforcement strategies. So that can give you help you in the implementation of enforcement strategies, and it can help you in the policy making. Okay, so that's all about heat maps. The theory of the heat map, that is mainly divided into three parts. What is heat map, types of the heat maps, and application of the heat maps. And the next videos we will do, I will explain how we can create a heat map in Python and R. So this is, I think this is enough for today, and see you in the next video. Ciao.